Please give a warm welcome to Josip Domšić.
Hi. Hello, everybody. My name is Josip, and I'm an engineer at Reversing Labs. I'm here to give a talk about the evolution of object storage within Reversing Labs. But before I begin, let me tell you about myself. As you might have guessed from the title of this presentation, I'm really into cooking. So if you like a recipe for any of these pictures you see on the screen, please catch me outside. And the picture on the bottom left is when I was at Mljet. So this is the peak of the island of Mljet in Croatia. So let me tell you about the presentation So at Reversing Labs, we have a 2.5 petabyte of object storage. It could be more by the end of today, but let's keep it at 2 petabytes. It all began in 2008 with a business decision to preserve all the files we receive. And it continued to grow until today, and it stopped at 2.5 today, 2.5 petabytes. And we have a plan to grow further 1.5 petabytes or 4 petabytes by the end of next summer. After that, we will see how it goes. Somebody asked me, why do we even save those files? Well, it's a business for us. We do static analysis and dynamic analysis of those files. We do it continuously. That's why we save them. We did it beginning of 2008, and it continued out to today. Static and dynamic analysis is not the only thing we do. We do also antivirus scanning, machine learning, file classification, and so on. In 2008, it all started with the first file, and somebody from the upstairs said, please save this file, we're going to need it sometime in the future. And of course, the first developer on the job just saved it in a download folder, and it kept it there for a long time until it got deleted. So the first file we got, it is deleted. So it was pretty much a startup back then. And after that, okay, since we are losing those files, we need to create some kind of dedicated object storage for it. And the first plan was, okay, find an open source solution. At that time, there was GlasserFS, so we went with that. We used it for 2-3 years, and it got replaced with BGFS. Community at that time was pretty keen on maintaining the new shared file system named BGFS. And with that, we used it also for 2-3 years until the maintenance plus the stability of those file systems couldn't really keep up with our demand. We got around 3 million files per day, new ones, and the total number of files at that time was around 1 petabyte. Both of those file systems were pretty much on the peak of their abilities at that time, and business decision was, okay, we need to find something else. So the testing started. Pretty much it started with a brainstorming session. We talked about, can we use torrent protocol for it? Can we use Hadoop? Yes, of course we can use everything of it, but none of the developers and sysops at the time really had that much experience with those technologies to use for our purpose. So let's try to develop something ours that could be much simpler than those protocols, could be dedicated only for those things that we need. And we got with an idea to create something like this. we have an external application that uses those samples. It can be anything, like I said, for antivirus scanning or similar. Let's create a database that stores metadata and use servers with a lot of these spaces to preserve those files. And in between, library for a glue between the database for metadata and servers with those files. Metadata is just location, timestamp, and let's say file size. Let's dig a little bit deeper into library. It's a really simple library that has only 2 or 3 main operation. It's get the file, put the file somewhere, and delete the file. Mostly get and put are used. Delete is a special possibility. It's pretty much almost no use for all our use case. As I said, metadata is a location. So you have to know where the file is. And since you know it, you can just put it in a multiple location to support either load balancing or whatever your real needs are. The database, this is a tricky part. Since you have 10, 20 developers, most of them are accustomed to their own databases. They grew fond of them. But we wanted to create a file system, shared file system, that can support any database. So if you go with this recipe, you can really use any SQL or non-SQL database. We use non-SQL since we generally do not use any grouping abilities of SQL database or subselecting. Our main goal is to please have this file name. I want to get this file. Currently, our database supports about 15 million operations per day. Of those 15, 12 million operations are the get operation. And as I said, 3 million new files. This is it, 3 million file inserts per day. Those files really range from few kilobytes for, let's say, malware files, and some goodware files can be up to 1 terabyte. So you have to create a file system that supports really small files and a big one as well. You may ask, what is the average file size of a sample or a file we have? It's 1 megabyte. So when you download almost everything you find on internet, it will average around 1 megabyte. So 15 million operations per day times 1 megabyte per file, it's 15 terabytes of traffic from your shared file system. So this is the database and the library, and we are left with storage servers. So this wouldn't really be a talk about web if we don't use a web server. All the glue part that's managed by a library, the file servers, are really just map this HTTP request to a path on the disk. So we use supported libraries or plugins within a web server. You can use like we do, the Nginx WebDAV plugin. As you can see from the metadata from the Nginx configuration, you just need to put a root folder. It's a dummy data file. Then you can use DAV methods like put, delete, copy, move. And the create full path is, like I said, from the library's metadata location. This is it. If you put a whole path to the file within your library, you just use this configuration, and this is it. You have a working web server that has 10, 20 terabytes of files, and the library just points from the location to the file system. Also, the configuration for Apache is similar. You can, in both of them, you can use the username, password, accepting only known IP addresses, but that's up to you. When talking about file servers and location, you have to be smart about naming files that grow by 3 million a day. You have to have a unique naming schema. We use a cryptographic hash, and we avoid unique. How do you say? You avoid duplicate naming by using cryptographic hash algorithms, meaning SSH1 or SSH256 and similar. For load balancing, you can use multiple servers and just create a simple round robin in the library, meaning please place this file somewhere. Library decides, okay, server 1, server 2, and put that into configuration. So when you add an additional server with additional disk space, just reload the library and it will decide on the old servers and new servers. Also, as I said, there are quite a few smaller samples, meaning you have to have a file system that supports the small, really big number of small files. So we went with the XFS file system. And it proved really, really good for those things that we wanted. That's pretty much it. There is nothing more else we can extract or remove from those, either libraries or web servers or metadata. That's pretty much 150 lines of code, one server for the database, and let's say 10 other file servers. If you have any questions about it, I'm eager to listen to them. You can point it right now.
Thank you. Any questions?
Hey, just a very quick question. Can you go to the previous slide? You said that the path is very simple. There is basically some root path and then the hash of the file content, right? Not the file name.
Can you repeat it, please?
So you're storing the file as path and then hash of the file content.
No, the web server are the files themselves. Their name on the server is the hash.
Okay. So you have in the same path literally like millions of files in the same directory.
Okay.
How does that work for XFS?
Well, you have to create a separate folder for each of the file, multiple file. So split it in, let's say, 2-3 bytes of the file. It works very well with XFS if you do one trick. So Linux file servers do really good name caching. So if you use first 2 or 3 bytes of the file for caching, it will prove to be a bad decision later on when you have, let's say, 1 million file of the same name at the beginning. So you use last 2-3 bytes of the name for the folder name, and you do, let's say, two subfolders.
But that's my question. Like, why do you use hashes of the file names instead of the file content?
It's the hashes of the file content. It's SSH1 of the whole file, not the file name.
Okay, and then just to wrap it up, what about solutions like React, which were meant to do exactly this, just this, like open source S3? It's even compatible with Amazon S3.
Okay, when we started this, S3 was not production ready. So this is the answer to the question. When we started, there was no S3. If there is S3 now and we wanted that solution, we will probably use that.
Any more questions?
Hi.
Hi.
Do you use different file systems or do you use only XFS file systems?
We only use one. It proved to
Because-
be really good.
I thought that the load balancer maybe decides where to put smaller files on server 1, 2, 3 and larger files onto other servers which can support large files.
Yeah, that will be a good addition later on. For now, we wanted to keep it as simple as possible, since the library doesn't really know what the file size or the file name is before it decides where to put it. This is a possibility that could be added later on, but the XFS really proved to be good with both smaller files and larger files. We don't have an issue with that now.
Another question? Anyone? I have one. What do you do for backups, replication of data, and
Library supports any backup you really need. You can use OS level RAID 6, or you can just copy the files you put on the file server somewhere else. Well, the backup is the decision that's out of scope for the library itself and this design. Backup is for the engineer that do really backup.
Okay. Thank you. Any more questions? No? Thank you.
Bye.